Hi guys, welcome back to the channel. In this video, we will be solving a problem on projectile motion that is thrown from a height with an angle. So the problem states that a ball is thrown 5 meters above the ground with a speed of 40 meters per second at an angle of 30 degrees from the horizontal. So ignoring air resistance, find the amount of time that the ball will be in the air, the maximum height reached by the ball from the ground, and the maximum horizontal displacement reached by the ball. So we know that in projectile motion, we have the x and y component of the velocity. Let's break down the formulas first for the x and y components of this projectile motion. So for the x component, we know that the initial velocity at the x component is equals to the initial velocity at which it is thrown times the angle, but this one is in terms of cosine, so it's cosine theta. And then we know that the velocity at any point in the projectile, when we're talking about the x-axis, is equal to the initial velocity at the x-axis as well. This is because there's no change in velocity due to the fact that there's no acceleration in the x direction. Acceleration is only due to gravity, and that is in the y direction. Okay, and then the displacement in the x component is equal to this times the time. For the y component, we will be following the four kinematics formula for this. Okay, and we know that VOY is equals to VO, but instead of cosine, we use sine theta. And then VY is equal to VOY minus GT. And then we have SY is equal to VOYT minus 1/2 GT squared. And Vy squared is equals to VOY squared minus 2G SY. Okay, so the ball is actually thrown from a height. So let's draw a height here, and then the ball will go from here. It will reach a maximum height, and then it will eventually fall down to the ground, right? And then it is thrown at an angle of 30 degrees. So this one is VO, and the angle here is 30 degrees Celsius. This is the x component of the initial velocity, and this is the y component of the initial velocity. Okay, and this is the maximum height. And at the maximum height, we know that Vy is equals to 0. So there's only the x component there. And then here, that this is the point at which the ball will fall. And you're looking for this distance and this distance. And before we can find that, we have to find the time that this path takes before it reaches the ground. Okay? You have to know also that at every point in this projectile, there is always the y component and the x component. And this one is the actual velocity or actual angle of the velocity at this point. And in here, instead of the y pointing upwards, it will now point downwards because it will start to fall. But then the x component is always pointing towards the right. It's always pointing at the direction at which the ball is thrown. If this is towards the right, then the projectile, the x component of the projectile will always be pointing towards the right. So this is Vx, and then this is Vy. And likewise here, this is Vy, and this is Vx. And then this is the actual angle. Okay? So now, it's asking for the time. In order for us to find the time, let's use this formula. The displacement in the y component, it's actually just the negative height. This is because even though this ball reaches this point that is higher than 5 meters, it will eventually fall back at this area or at this point. So do we count that if we're talking about displacement? No. If we're talking about the distance, then we will count. But if we're talking about the displacement, we don't, because in displacement, the direction is important. So if it just goes back to the original height, then there's no displacement at all if we're talking about the y-axis. Okay, so in here, we don't take into account this height. So this one is just negative because it is lower than the original height. If this is 5 meters, if it's 5 meters lower than the original height, then it's negative 5 meters. That is the displacement in the y-axis. Sy is equals to VOYT minus 1/2 GT squared. So Sy is negative 5 meters is equal to VO. VO is 40 meters per second times VOY times sine 30. And then the time, that is the unknown, minus 1/2 9.81 meters per second squared. And then let's multiply it by t squared. So using quadratic equation, we will see that t is equal to positive 4.31378 and negative 0.23631 seconds. But since time can never be negative, so this one, we reject this answer and we only take into account this. So the time that the ball took is 4.31378 seconds. Okay? Now, calculating for this height. So at the maximum height, we know that Vy is equals to 0. There's no speed. When it reaches the maximum height, the velocity in the y-axis is equals to 0. Therefore, let's use this formula here to take into account the distance here. Okay? So Vy squared is equals to Voy squared minus 2GSy. And since this one is 0, we can cancel it off. So Voy squared is simply equals to 2GSy. So Sy is equals to Voy squared is Vo sine squared theta. Oh, we squared this also over 2G. Okay, so Sy maximum is equal to 40 meters per second squared times sine squared 30 degrees Celsius over 2 times 9.81 meters per second squared. And the answer here is 20.38736 meters, because we know that this meter squared per second squared will get cancelled off, and then meter squared divided by just 1 meter, one of the meters will remain. So that is our unit here. But then this is the height from this point. So this one is 20 meters. This one is 20.39 meters. So if we want to take into account the entire thing, we have to add 5 meters to that. So Sy max from the ground is equal 20.38736 meters plus 5 meters. That is equal to 25.38736 meters. So that is your answer for part B. For part C, we are simply going to use this formula since we have found the time that it takes for the ball to take down that path. So Sx is simply equal to the initial velocity 40 meters per second times cosine 30 times the time, that is 4.31378. 0.3137 seconds. So you can see that the seconds will get canceled off. And again, we will have meters as the answer for this part. That is equals to 149.43 meters. And that is our answer for part C. And our solution is complete. So I hope you guys learned a lot from today's video. Thank you for listening and stay tuned for the next one. Goodbye.